Good day and welcome to our class on Riemann sums. In the last class, we looked at how to find the area under the curve using Riemann sum. We were able to solve one example. In today's class, we'll be moving ahead from there by solving also example on how to approximate the area under the curve using the Riemann sum. Let's look at this example. It says find the area of the region below the curve y equals minus x squared plus 5 on the interval 0, 2 using the upper Riemann sum with 5 rectangles. We want to approximate the area under the curve. Recall that area under the curve A is given as what? Summation f of t sub I delta x, where I ranges from I equals 1 to n, where delta x is the width of the subintervals and C of I represents the tag or sample points in each of the subintervals. For this question now, our interval is 0, 2. That's our interval 0 to 2. We need to determine what is the width of each of the subintervals. Our delta x is b minus a over n. What is our b? Our b is 2. Our a is 0. And our n is 5, the number of rectangles. So we have what? Delta x to be 2 minus 0 over 5, and that is 2 over 5. And so with this, that tells us that the distance of each subintervals is 2 over 5, this 4 over 5, 6 over 5, 8 over 5, and then the last one, 2. That is our delta x. Now the area under the curve, remember we are told to use the upper Riemann sum. Upper Riemann sum. What are our subintervals from here? Our subintervals are 0, 2 over 5, 2 over 5, 4 over 5, 4 over 5, 6 over 5, 6 over 5, 8 over 5, and then 8 over 5, 2. If that is our subintervals, using the upper Riemann sum, for this question means we want to take the right endpoint. That means our tags are what? 2/5, 4/5, 6/5, 8/5, and 2. The right endpoints of the subinterval. Therefore, the area under the curve, area A, will now be what? Summation of I equals to 1 to n of f of ti delta x. Remember, we have gotten our delta x to be 2/5. This is the same thing as saying what? Delta x into the summation as I moves from 1 to n of f of t sub I. And that is what? 2/5 into what? F of 2/5 plus f of 4/5 plus f of 6/5 plus f of 8/5 plus f of 2. That means we need to find the value for each of those. Our f of x from the question, which is our y, is giving us what? Minus s squared plus 5. So we need to find for each value when x is 2/5, when x is 4/5, when x is 6/5, when x is 8/5, when x is 2. I am sure we can do that. That gives us our A to be 2/5 into what? 4.84 when our x is 2/5, 4.36 when our x is 4/5, 3.56 when our x is 6/5, 2.44 when x is 8/5, and then 1. The area under the curve gives us 2/5 into what? 16.2. And that is what? 6.48. Finding the area for the region under the curve using the Riemann sum. So with this, you can try your hands on this one. You can try your hands on this question and see how much of what we have done today that you can do. Approximate the area bounded by the curve y equals to x squared and the x-axis over the interval 0, 1 using the lower Riemann sum with 4 subintervals of equal width. Let me give us a hint as to how we are going to solve this. Remember, our interval is from 0, 1, and we have 4 subintervals. That tells us that our delta x will be what? B minus A over n, and that is 1 over 4. Therefore, our interval from 0 to 1, we have 1 over 4, 2 over 4, 3 over 4, and then the last one, which is 1. And so the subintervals are what? 0, 1 over 4, 1 over 4, 2 over 4, 2 over 4, 3 over 4, and then 3 over 4, 1. Those are our subintervals. But we are using what? For this question, you are to use the lower Riemann sum. The lower Riemann sum. Because that in this example, when we are using the upper Riemann sum, we use the right endpoint. But for the lower Riemann sum, we are going to be using what? The left endpoint. That means our tag will be what? 0, 1 over 4, 2 over 4, 3 over 4. Finish it up from there and leave your answer in the comment section. Have a beautiful day. Thank you.